All right, we are continuing with ratios. Yesterday we did models where you drew your own models. Today they're going to tell you what kind of model to draw. It's a specific one and how to use it to find equivalent ratios. But first we are going to review writing ratios. So it says the local bakery sells muffins in a variety of packs of blueberry, pumpkin, and bran muffins. They always sell the muffins in the ratio of 3 blueberry muffins to 2 pumpkin muffins to 1 bran muffin. So for A through F, you are going to read the description and you're going to write the ratio for each relationship and tell me if it is a part-to-part or a part-to-whole relationship. Any questions? This should only take you 3 or 4 minutes to do A through F. Again, you're writing the ratio and whether it's part-to-part or part-to-whole. You may begin individually. What is my ratio of blueberry muffins to total muffins for A? 3 blueberry to 6 total. Is this a part to part or part to whole ratio? It is a part to whole ratio. B, pumpkin muffins to total muffins. Chloe? Pumpkin muffins to total muffins. All right, is this part to part or part to whole? It is a part to whole relationship. All right, bran muffins to total muffins. Owen?
1 bran to 6 total.
And is that part to part or part to whole? Blueberry muffins to pumpkin muffins. Somebody different. Ian? 3 blueberries to 2 pumpkin. Is that part to part or part to whole? Now we're at part to part. Bran muffins to pumpkin muffins. Easier? Part to part or part to whole? Part to part. And blueberry muffins to bran muffins. Drew? Good job, guys.
You wrote 2 blueberry muffins. It's 3.
Thank you. It's Friday. All right, so yesterday we drew pictures for our models. Today we're going to use a specific model called a tape diagram. A tape diagram illustrates the number relationships in a ratio. It represents the parts of the whole. So, for example, we had our box of muffins that came with 3 blueberry, 2 pumpkin, and 1 bran. Yes? So they represented it using a tape diagram. Each part of the box is represented. What does each of those small rectangles represent?
1 muffin.
1 muffin. All right, so let's look at the next page. It says, suppose you purchase an 18-pack of muffins. How many blueberry, pumpkin, and bran muffins would you purchase? Blah, blah, blah. So remember, they only sell them in packs of 3 blueberry, 2 pumpkin, 1 bran. Yes? But now we're buying a total of 18 muffins. So all of that is going to equal 18. How many pieces am I breaking that 18 up into? How many pieces do I have in my tape diagram? I have 6. I have 1, 2, 3, 4, 5, 6. Yes? And if I'm breaking up a number, am I multiplying or dividing? Dividing. So 18 divided into 6 pieces, what would go in each box? 3. So how many blueberry muffins would there be? 9. How many pumpkin muffins would there be? And how many bran muffins? Does everybody understand how we did that? Okay. First thing, is the ratio 9 to 6 to 3 that we just did equivalent to 3 to 2 to 1? Think back. How do we know it's equivalent or not? And explain how you know. You have about 2 minutes to talk it out as a table, get your answer, and then we will come back and discuss. Go for it. Who thinks yes, they are equivalent? Who thinks no, they are not equivalent? Okay, who can tell me why? Go ahead.
They are equivalent because you can get them both to an equal amount. Because the first one, if you multiply it by 1, it stays the same, and the second one, if you multiply it by 3, every number in it by. If you multiply in the first ratio every number by 1, well, you can get them to an equivalent.
You kind of confused me.
Yeah, I was confused myself.
How do you know when a fraction or a ratio is equivalent?
Okay, so 3 to 2 to 1 is just a times 3 away of each of them to 9 to 6 to 3.
So in order for it to be equivalent, it needs to be multiplied by the same number every time. Or divided by the same number every time. In this case, we're multiplying. So if I start with my original ratio, what do I do to 3 to get to 9? What do I do to 2 to get to 9? I mean 6. Times 3. And what do you do to 1 to get to 3? So are they all multiplied by the same number? Yes, then we know it is equivalent. If they were not all multiplied by the same number, it would not be. Make sense? All right, so using that information and the example we did at the top, I want you to see if you can answer number 4 and 5. You may work as a table, and I'm giving you about 6 minutes to do these two, and then we will come back and discuss. Go for it. So number 4 says, suppose you purchase a 36-pack of muffins. How many blueberry, pumpkin, and bran muffins will you receive? So again, they brought us back to that original ratio, simplest form. They sell it in packs of 3 blueberry, 2 pumpkin, 1 bran. Yes? So if we buy 36 of them, is that 36 blueberries? 36 pumpkin? Bran? No, it is all together going to equal 36. Yes? So what am I doing to that 36? Into how many pieces? I'm breaking it up into 6 pieces because I have 6 rectangles in my tape diagram. Yes? So what is 36 divided by 6? So each box gets 6. How do I know it's equivalent?
Because you can add all the 6s together to get 36.
And because all the numbers are the same. If they were different, it would not be equivalent. So how many blueberry muffins? How many pumpkin muffins? And how many bran? All right, use that information to do number 5. It is a little different, but not that different, and you should be able to troubleshoot it. Go for it. Suppose you wanted 20 pumpkin muffins. How many total muffins will be in your pack, or how many will you have to purchase? So it gives us 20. Does that mean that they're only buying 20 muffins? No. What are they buying 20 of?
Pumpkin.
So I find pumpkin, and I know it is 20. Well, this time I only have how many pieces? 2. I have 2 pieces for pumpkin that I am breaking that 20 into. Yes? So if I break that 20 into those 2 pieces, what goes in each? And what do I know about equivalent ratios? They all have to have the same number. Yes? So how many blueberry will I have? And how many bran will I have? And in all, I will have 60 total muffins. Any questions about that? All right, so we have been doing a lot of talking about equivalent ratios. So, it is your turn to make equivalent ratios using this table. 2 of them we have already done. We have done a 6-pack of muffins, and we have done a 36-pack of muffins. So if we look back, how many blueberry are in a 6-pack of muffins? 3. How many pumpkin? How many bran? How many blueberry are in a 36-pack of muffins? How many pumpkin and bran? So it's already halfway done for you. It's actually more than halfway. I want you to finish the table for 12 and 24, making equivalent ratios for those muffins. Any questions? All right, I'm only giving you about 2 minutes, and I want this individual. Equivalent ratios, you have to do the same thing to each number, yes? I always start with the simplest form ratio, so that would be our 6-pack in simplest form. What do I do to 6 to get to 12? So that means I'm doing that all the way down. 3 times 2 is? 2 times 2 is? 1 times 2 is? Equivalent means you're doing it the same thing to every number. Make sense? Again, I'm going to start with my simplest form, which is 6. But what do I do to get to 24 now? Times 4. So I have to do that all the way down. What is 3 times 4? 12. Again, I'm doing this row, simplest form. 3 times 4 is? 2 times 4 is? 1 times 4 is? Just that easy. Do the same thing to every number. Then you can see a pattern. You're counting by 6s. Then, not 2s. 3s, then 2s, then, and it makes a pattern. Yes? That's another way you can know they're equivalent, because if it didn't make a pattern, something's off. All right, we're going on to the next page. Coach Roberts wants to encourage her swim team to increase their speed. She will give an award to the member of the team who can swim the most laps in 20 minutes. The table records the results from this week's practice. So they have 4 swimmers on the swim team, and this is how they did at practice this week. Pia and Lisa both guessed at who they think is going to win. Tia said Susan will definitely win the award because she swam the most laps. Lisa said it took Susan the longest time to swim her laps. She will not win the award. You're going to talk it out as a table and tell me who's right, who's wrong. Are they both right or are they both wrong? And then I want you to actually find out who is going to win the award. And show me mathematically, not guess. So you're answering who is correct, who's not, or are they both right or wrong? And then telling me who will win the award by working it out mathematically. Go for it. Who thinks Lisa is correct? Who thinks they're both correct? Who thinks they're both incorrect? You didn't even have to read them, guys. It tells you. They are both incorrect because they didn't compare them accurately. They did no math. So let's look at Kay. Kay can swim 4 laps in 5 minutes. What do we know from our problem that we need to get to? What's part of the award? The most laps in, good Lord, 20 minutes is the only other information we have. So what am I doing to 5 minutes to get to 20 minutes? by 4. So I have to do the same thing to the other side to make an equivalent ratio. So how many laps did she swim in 20 minutes? If you did not do the other 3 the same way to show it mathematically, I'm going to give you about 2 minutes to do that, and then we will come back and discuss who won. Go for it. Susan did 7 laps in 10 minutes. And again, the competition is going for 20 minutes. So what do I do to 10 to get to 20? So to make it equivalent, I do the same thing. So 7 times 2? 14 laps in 20 minutes. Then I have Doug, who did 1 lap in 2 minutes. And all of them have to swim for 20 minutes. So what did he do? Times 10. So 1 times 10? 10 laps in 20 minutes. And then Mako, who did 3 laps in 4 minutes. So what do you do to get to her 20 minutes? By 5. So 3 times 5? 15 laps. So looking at this, who swam the most laps in 20 minutes? Kay. Kay wins the award. Five. This type of ratio is called a rate because it compares quantities that have different units. We were talking about laps and minutes. This also works for miles per hour or anything that has to do with something going how fast in a certain amount of time or how slow in a certain amount of time. That is a rate. Does that make sense? Whether you're talking about minutes, hours, days, months, it is still an amount of time, and somebody is either going fast or somebody is going slow. That's a rate. All right, we are looking at the bottom of the next page. When we went from 4 laps in 5 minutes for K to 16 laps in 20 minutes, that means we were scaling up. We made an equivalent ratio by multiplying both parts by the same number. So if that's scaling up, because I made it bigger, what would be the opposite? Scaling down. And instead of multiplying, I would divide by the same number. Make sense? We are skipping the next page, and we are going on to the page after that. It should look like this. Again, scaling up is making equivalent ratios by multiplying both numbers by the same number. So, for example, number 1a, you always start where you have the whole fraction, where you have a number for your numerator and a number for your denominator. Why? Because if you start with the other fraction, do you know what the question mark represents? No, that's what you're looking for. It doesn't help you find the answer. So you start where you have a whole fraction, and what would you do to get from 3 to 27? So 1 times 9? 9 yards. That is all you are doing. Got it? I want you individually to answer B through C and number 4 and 5 at the bottom of the 3 and 4 at the 2A and B at the bottom of the page. It's Friday and I'm tired. So you are finishing B, C, and D, and then you are finishing number 2. Any questions? This should be easy peasy. I'm going to give you about 5 minutes to do it. Go for it. Again, you start with the whole fraction that has a numerator and a denominator, not the one with the question mark. What do I do to 2 to get to 30? Times 15. So I do the same thing to 4 and I get 60 cups. All right. This time my question mark is at the top, so I'm going to start at the bottom. 3 to 9. Times 3. So 36 times 3? 108 inches. All right, 20 to 80 times 4. 5 times 4, 20 gallons. All right, so Jenna buys 2 pizzas for every 6 people she invites to a party. How many pizzas will she need to buy if she invites 18 people? So let's talk about it. What is my ratio? 2 pizzas, 6 people. Yes? And we know from our problem that she is inviting 18 people. Notice the people are both in the same place of the fraction. They're both at the denominator. You cannot have one in the denominator and one in the numerator. It will not work. The order matters. Does everybody remember that? Okay, so what am I going to do to 6 to get to 18? Times 3. So 2 times 3? 6 pizzas. And it is a word problem, so you have to put word answer. All right, Stefan runs 5 laps in 6 minutes. How many laps can he run in 30 minutes? So what is my ratio? 5 laps to 6 minutes. And what do we know from our question? 30 minutes. So what do I do to 6 to get to 30? So 5 times 5? 25 laps. So he can swim. Sorry, run. Did we do swim earlier? Yeah. Oh, that's the problem. 25 laps. Any questions about that? So this is called what? Equivalent ratios by, what's it called when you're making them bigger?
Scaling up.
Scaling up. So guess what we're doing next?
Scaling down.
We are scaling down, and I'm not going to do an example with you because it's exactly the same, just the opposite operation. I want you to do numbers 3 and 4. So basically the whole page, and you have about 9 minutes. Go for it. As a reminder, you start where you have a whole fraction, a top and a bottom. So I start at 6. What do I do to get to 2? So what do I do to the bottom? And 18 divided by 3 is? And I keep writing the answer. There we go. 6 people. What do I do to 25 to get to 5? Divided by, wait, what? Divided by, there we go. 100 divided by 5? 20 track shirts. What do I do to 3 to get to 1? Divide by 3. So $26.25 divided by 3. And what do I do to 12 to get to 4? So 720 divided by 3. Any questions about the top part? All right, Mark bought 12 pounds of bananas for $15. How much does 4 pounds of bananas cost? So what is our original ratio?
12 pounds of bananas, $15.
12 pounds to $15. And what do I know from my question?
4 pounds of bananas.
4 pounds. So what do I do to 12 to get to 4?
5 by 3.
So 15 divided by 3?
5.
It will cost $5. My brain has shut off for the weekend already. All right, 750 words in 6 minutes. If she types at the same rate, how long does it take her to type 250 words? What is my original ratio? And what do I know from my problem? 250 words. So what do I do to 750 to get to 250?
Divide by 3.
I'm dividing by 3. So 6 divided by 3? 2 minutes. Are there any questions? Okay, you can tear out your homework, page 209 and 210. Yes?
I have a comment. I also found the WPM for WPM is 125 words per minute.
Yes. Good job. All right, 209, 210. Then you may rock, paper, scissors as a table to determine who's putting up books today.